Hi and very good afternoon to you. It's Jim from maverickstar. It is the 17th of the month, and as you guys know, on the 17th we do a calculation as to where the exact position is of the magnetic North Pole, which we'll be getting into a little bit later on in the video. Big thanks to Nathan, Philip and Sydney for your support yesterday, and you know, the only thing is at this point to say is, guys, there is a link down there in the descriptions if you want to help support our observatory. You may have noticed over the last week or so we've been trying to clear up a deficit that was built up over the last 18 months of COVID-19, and you know, we've got a deadline for that in January. Anyhow, let's get on with the topic that you're here for. Just before we do though, I just want to say, did you watch the video yesterday where we used, you know, the mainstream media's climate charts to prove that, you know, there is an effect also being had with the magnetic North Pole migration? In fact, the chart that we're looking at right now is the chart that we used. The only thing that we added to that chart, if you watched the video yesterday, was the two lines, one indicating from the beginning of 1900 and the other to 1990. And the significance of that is, as you've been following us, you'll know that the magnetic North Pole has from the 1900s to 1990 migrated 500 miles, but from 1990 to the present day it has migrated over 1,000 miles. On the chart that we was looking at yesterday with global temperatures, what had happened since 1900 was, in the 90 years up to 1990 it had increased by only 0.5 degrees Celsius in temperature, but from 1990 to 2020 it had increased 1 degree. And you know, there is no coincidence there. You know, where the peak starts at 1990 is exactly where the peak starts on the increase in temperature which mainstream media put out, but they fail to mention the magnetic pole migration every time. You have to ask yourself, why is that? So here's the latest TriMag data processed today by myself. As you can see, things have been a little bit calmer with regards to the bumps in the sine wave of the heading data, but it doesn't mean that that has affected the speed of the migration, and also is still falling in line with a 20% increase. I think we've got we're going to have a look on Google Earth shortly. I think we've got a 5.1 or 5.2 mile increase over the last month, which is, you know, again around about 20% increase. So the magnetic North Pole is still holding its current trend that we've seen in the last 5 years. You know, we've still yet to decide why that is the case. We know that at the moment it's crossing the mid-North Atlantic ridge at this present time. We know that since it started to cross the ridge line over the northern hemisphere, it increased by around about 20%. Is it because it is crossing over the ridge? Will it slow down, or will it continue to increase as we get closer to that 40-degree mark? I see a lot of people questioning what the 40-degree mark is, and this is just a mark that we've added, which is a calculation of the total migration up to 40 degrees. And the reason why we've got the 40-degree mark there, and we'll have a look on Google Earth in a minute, as you'll see the magnetic North Pole month in, month out increasing towards that 40-degree mark, it's just an indication of experiments that was conducted by myself a few years ago, where I was studying the effects of weak and strong magnetic field line interactions, and what happens when poles cross that 40-degree mark is usually they start to wander and accelerate rapidly into the reverse. So we are assuming that that will be the case for the Earth's magnetic field when it gets around about to the 40-degree mark. What is the timeline? How long have we got? It's around 17.1 months now out and we should be at that mark, and we are expecting at that point to see a significant increase in the speed. But I will say this, what we're seeing right now is only in the last 5 months a fluctuation in the speed, so it has increased and covered more distance by around about 20% in the last 5 months, but we still have that hanging over us. Is it because it's crossing you know, the active volcanic region under the ocean on the North Atlantic ridge? So let's go over to Google Earth, have a look at where the latest position is, and give you guys the longitude and latitude of the current position of the magnetic North Pole. So here we are over at Google Earth. As you can see, the last month's distance is 5.2 miles, maintaining that 20% increase that we've seen constantly now for over 5 months. And I will zoom out so you can see where we have began 5 months ago, crossing the North Atlantic Ridge. And for those that are following it on their own Google Earth maps and they want the pin latitude and longitude, they are as follows. So the latitude is 82 degrees by 51 hours 40 minutes 4 seconds north, and the longitude is 120 by 36 hours 30 minutes 82 seconds east. And I'll just close that down so you can see the actual distance that it's covered. Sorry, it's 5.09 miles, so just under 5.1 miles in the last 30 days or so. So there you are, guys. I'm going to zoom out so you can see now where we are over the Atlantic Ridge and where we are with regards to the corridor that we've been tracking, and how close we are to the 40-degree mark. You'll just see now coming into view the ridge. I'm just going to clear the ruler tool off, and you will see we are now almost slap bang over the mid-Atlantic Ridge over the northern hemisphere, and you can also see how close we are to the 40-degree mark. We know in which direction the pole is likely to end up at some point in the future. If we just zoom out, we can see there the new North Pole mark is in central Russia, just below the Arctic Circle and just below Siberia, and that's where the magnetic pole is heading. We know that that's where the intensity over Russia is increasing. Some of the other things we can predict might be the case is that the Arctic climate could be moving over there, and the reason why we say that is when we look at temperature charts and magnetic intensities, they are showing pretty much the same picture. The other thing to add is that we do currently have 2 magnetic poles over the northern hemisphere and 2 over the southern hemisphere, although when we look at the southern hemisphere, and we'll have to pull up the charts in the next few days so that you get a better idea. I know it's difficult to see that when we're looking at Google Earth maps, but take my word for it, we have one over the northern hemisphere in Canada. As you know, that one is weakening, and that is why the pole has begun to migrate over the northern hemisphere. We also have one in Russia where the magnetic pole seems to be heading directly towards, it's not far off the corridor that we're in line with, and that could start to accelerate over the next 17 months, especially when we cross the 40-degree mark. So things are starting to get a little bit more exciting, and I've always said this, that there is a lot more going on with the Earth's mechanics which is involved in magnetism than what mainstream science tells people about. I believe that the only reason we are experiencing an increase in climatic changes that we have done over the last 30 years is a direct result of the magnetic poles increasing or doubling in their speed over that time period, or even tripling. I'm talking about that point from 1990 to the current day, whereas the magnetic pole has migrated over 1,000 miles. And when we cross that 40-degree mark, it could increase again over that point in time. But at the same time, we should expect changes in the climate and seeing more of the things that we've been accustomed to seeing over the last few years, at least, with an increase, an uptick in floods globally. Guys, there's a link down there if you want to help us. This observatory, again, we're trying to clear off a deficit that we ran up over the last 19 months because of COVID-19. We don't want to have to alter the service that we give, and at the end of the day, this is the only observatory I know of which is covering the magnetic North Pole in the detail that we are, and we do have our own best spec equipment that tracks it here at the observatory. So there are a lot worse things you can do than support a scientific observatory, which is, you know, probably talking as much as what we do here on probably one of the most dramatic things that this Earth has gone through in the last 780,000 years. That is, as you already know, the magnetic North Pole reversal. Guys, links down there in the description, and I'll say what I usually do. You have a great afternoon, take care of your loved ones, and as always, bye for now.